Have you ever wondered how a computer program can learn to play a game, navigate a maze, or even drive a car? Welcome to the fascinating world of Q-learning, a crucial element of reinforcement learning used in artificial intelligence. Dive with me into the realm of Q-learning, a model-free algorithm in reinforcement learning where the goal is for our agent, be it a game-playing bot, a self-driving car, or a maze-navigating robot, to learn a policy. This policy guides them to act in a way that maximizes the sum of rewards over all steps. So, how does this work? Step 1. Initialize the Q table. This table stores the maximum expected future rewards for each action at each state. It starts with arbitrary values and then updates as the agent learns from its experiences. Step 2. Observe the current state. The agent must understand its current situation before deciding on an action. Step 3. Select an action. The agent can either exploit what it has already learned, or it can explore new actions in hopes of finding better rewards. This is the famous exploration versus exploitation dilemma. Step 4. Perform the action and observe the reward and the new state. This is where the agent interacts with the environment, taking the chosen action and observing the results. Step 5. Update the Q table. The agent uses the observed reward and the maximum reward for the new state to update the Q value of the performed action. Step 6. If the goal state is reached, the episode ends and the whole process starts again. If not, the agent goes back to step 2, observing the new state and selecting the next action based on the updated Q table. This loop continues until the Q table converges to the true Q values, which indicate the expected sum of future rewards for each action at each state. Think of it like a child learning to walk. They take a step, maybe they fall, maybe they manage to stay upright. Regardless, they learn from the experience and adjust their strategy for the next attempt. Over time, their steps become more confident and coordinated, just as our agent's actions become more optimal as it learns from its experiences. In the context of Q-learning, the key points to remember are the Q table, which stores the expected future rewards for each action at each state. The exploration versus exploitation dilemma, where the agent must balance using what it knows with discovering new information. The updating of the Q table, which is how the agent learns from its experiences. The convergence of the Q table, which happens when the agent has learned an optimal policy. So there you have it. A simple yet powerful method for teaching machines to learn from their experiences. As the agent explores, experiences, and learns, it gradually hones its policy until it's capable of making the most rewarding decisions. That's the power of Q-learning, a cornerstone of artificial intelligence that enables machines to learn, adapt, and excel. Remember, the goal is not just to learn, but to learn optimally.